Hello everybody, thank you for joining today. My name is Venom and today we're going to be covering electrical currents. Now, some of our learning objectives include to understand that charge can only flow when there is a PD, potential difference, to recall the link between current and charge, and to be able to understand the difference between conventional current and electron movement. Now, the only real thing that you need to know already before you can tackle this video is that electrons are negatively charged, right? That's all you need to know, and I'm going to teach the rest to you. If you're ready, let's get right into it. Now let's have a look at our simple circuit diagram over here. Can you name these two components? If you said cell and resistor, well done, you got it right. Now, first of all, I'm going to introduce a brand new concept to you called potential difference. Or rather, PD, as it's usually shortened down, and this is given the symbol V. Now you might recognize V for voltage, but voltage and potential difference are often used to describe the same thing, but there are some slight differences that you need to be aware of. Now, potential difference just talks about the difference in charge. Now, if we take a look at our cell plates here, the long line, as I told you before, is the positive plate, and the short line is the negative plate. But why is that? If I zoom in to the positive and negative plates here, so positive, negative, the negative plate is actually covered with electrons. Now remember, electrons are negatively charged particles that surround the nucleus of an atom. Now these negatively charged particles, because they're all bundled up on one plate, is what gives this plate the negative charge. But because these two plates are quite close by, a potential difference is developed across them. Okay, and because there's electrons on the negative plate here, the absence of electrons, so the fact that there are no electrons on the other plate, mean that it's automatically positive. Okay, now this potential difference across these two plates is what is usually labeled in a battery. So this could be, say, 9 volts. 6 volts or 3 volts, like that. So that's what we mean when we talk about potential difference. Now, why is this so important? Well, for charge to flow, there must be a potential difference. Now, what sort of implications does this have? Well, this is because if we have negative electrons over here, we know that opposite charges attract. So these electrons want to actually be on the positive plate, but can they just jump across this little gap? Well, for this exact cell, no, they can't. So instead, they have to travel all the way across the circuit to the positive plate, right? So they have to, all of this charge has to flow through all of our components here, in this case the resistor, to reach the positive plate. So for charge to flow, there must be a potential difference. Now, what's the link between current and charge? Well, current is the flow of charge. So when charge flows throughout the circuit here, we say that, oh, there's current in the circuit, right? Charge is flowing. Now, electrical current is always negative. Oh, that looks like H, negative to positive. Now you'll see in the next slide that there's something called conventional current, which is actually the opposite, which is a bit weird, but we'll get into that now. Okay, so now let's have a look at conventional current. Now this is a bit weird because it confuses students after they've just learned that, oh, charge flows from negative to positive, but conventional current says that current moves from positive to negative. Okay, so this would mean that if this is the positive terminal and this is the negative terminal, current, which is given the symbol I, is flowing this way through our circuit. Now you might be wondering, oh, I mean, why are there these two different conflicting definitions? Well, that's because conventional current was actually discovered well before we knew anything about electrons, before we even knew they existed. So we'd already named the terminals and already given this definition, and now we have to learn it as well. So remember that conventional current tells you that current moves from positive to negative, but in fact, electrical current, the charge, the electrons themselves move from negative to positive. Okay, it's conflicting, but you just have to get used to it. But now, let's have a look at how we would actually measure the current flowing through the circuit. If this circuit over here, this doesn't tell us anything, right? If we could connect this and we wouldn't actually see anything happen, right? So we need some sort of readout. We need another component in here that can tell us the current flowing through. And that is called an ammeter. Now, the important thing to remember is that ammeters are always connected in series, no matter what circuit you have. They're always connected in series. So here's our resistor as well, and this ammeter here will give us a readout. So always in series. This is ammeter. And now, if we have it connected this way around, so from positive to negative, the reading on the ammeter, so let's just make a fake screen here, right, will be positive. Let's say 0.05 amps. But say I was to connect the leads the other way around, this would actually end up giving me a negative number, but it would still give me the same readout, okay? And that would be because, the ammeter displays conventional current, okay? So we always want to connect it positive side to positive side and negative side to negative side to give us a positive reading. So that students often get confused about, why is my ammeter giving me a negative reading? Well, that's why, because you've connected it opposite to the conventional current flow diagram. So now you understand conventional current, electrical current, and the link between charge and current. Well done.